Hey everybody, welcome back. Today we're going to be taking a next step using our new optimizer. We're going to be learning how to export those results outside of our little Jupyter notebook screen and into a format that's going to be much easier to bulk upload to FanDuel, DraftKings, whatever it is that you're going to be putting your lineups in at. And I do apologize in advance if I sound a little rushed or scoot through things pretty quick this video. Already recorded it once. Realized when back to edit that my OBS recording settings were messed up and it was only taking like a chunk out of the middle of the screen rather than the whole screen. So, re-recording it in here Saturday morning. So you'll be seeing this in about 4 hours. So, with that being said, we're going to go ahead and take a quick sip of our energy juice here and get to it. So, same as before, we're going to go ahead and import what we need as far as specific modules out of the PyDFS lineup optimizer. We're going to go ahead and use FanDuel basketball just because that's what we've done the most with, so we're going to keep it consistent. Everybody's familiar with that format. We're going to load in our players from our CSV. Remember, this needs to be the player list from FanDuel or DraftKings, whichever website you're using. If you have your own projections, just drop those into the fantasy points column instead of the average fantasy points per game, and they'll just use those scores to predict your lineups. Also, apologies, my cats are going a little bit crazy right now, so hear any rustle and bustle in the background, just ignore it. Now, once we load our players into the lineup, so as previously shown in our last video, we can do for lineup in optimizer.optimize and equals 10 for 10 lineups, print each lineup out, and we get it in this format, which is perfectly fine if we're going to be manually putting our lineups in on DraftKings or FanDuel one by one, picking out each player. If you're only doing a handful of lineups, that's perfectly fine if you have the time. If you're trying to max out, a 25, 50, 100, 150 entry tournament, though, you're not going to want to manually sit down and craft each lineup like that. It's going to take forever. You're going to have to start at an hour before lock, and then injury news is coming in, and it's not a place you want to be. So to get around that, we can define our lineups object as the optimizer.optimize10. So instead of for lineup in that function, we're just going to define lineups as that function. We're going to go ahead and set that up again. Lineups equals optimizer.optimize for 10 lineups. And now we can just call optimizer.export because we've created our optimizer function. And now we need to export it. It's important that does need to be exported as a CSV. And now when we open the CSV, we're going to see that the way it's exported natively is not ideal for our purposes. So we're going to go ahead and run that. I'm going to open that CSV up, and we're going to take a look. So as we can see here, we have everything that we need. Right? We have the positions in the right order, our budget, our projected scores, but we're getting the names and the ID with a open and closed parenthesis around the ID smushed right up against the name, so there's no space or anything. So this is good for manually reviewing them, but we can do that in the Jupyter notebook, right? We don't need to export it to CSV and look at it. We can look at it right here. And this is, frankly, easier to digest than this is. Like, that just looks sloppy with the IDs and the names like that. So how do we get this into a format that we can work with? First things first, we'd want to go through our process up to this point, okay? So we have exported out to a CSV. We're going to need pandas, which normally you could have import pandas as PD up here. I just didn't want to ruin the surprise that we'd be working with pandas again today. We're going to read that CSV, so df equals pd.read CSV. We're going to pull that same CSV file in. We're going to take a look at it. So we can see right off the bat that pandas already did one thing for us. It took out that extra line in between each lineup. So that's wonderful. Now, what do we need to do next? We need to isolate the IDs, okay? And just return the IDs for each of these cells in the data frame. So how are we going to do that, you might be asking? We're going to be using some string operators. And as an example, we're going to use Chris Paul here because we're going to pull it out and we're going to just figure out what we need to do on him and then figure out how we're going to apply it to the data frame as a whole. So one string operation we can perform is the split operation. And what the split operation is going to do is, think of it as a comma separated value, CSV. If you've ever looked at one of those in a text editor like Notepad, it's just all of the values with commas between them, no spaces, and then there'll be a new line in for each row. But as far as each row is concerned, it's just value, comma, value, comma, value, comma. And then when you read into Excel, you establish the delimiter as a comma or as any other delimiter that's being used for that specific data set. You identify the delimiter, and Excel's smart enough to read it and say, okay, so every time I find a comma, I need to remove the comma and split the cell there. So there's a comma, that's the end of that cell. Everything before that up until the previous comma is in that cell. And then, afterwards, each cell, when it gets to the end of the line, drops down in the next row, starts it over again. This is basically what it's doing. So if we take a look at Chris Paul here, we want to split on the number 2, or the character 2 in that string. So if we look, if we are assuming that 2 is going to behave like a comma would, reading in our comma separated values, we're going to have a string that's going to be Chris Paul space open parentheses 5507. The 2's the comma, so the 2 gets dropped out, and that's the end of that string. The next string is going to be hyphen 96. Then we hit a 2 again, the 2 drops out, and what are we left with after that? 3 close parentheses. So let's see if that's what we get. And sure enough, it is. Almost like I've ran this before. It's crazy, right? So what you'll notice there is we do get returned a list. So when we split a string like that, it returns a list with each item in the list being each item from that string that got split. So it returns it in order, split in the manner that you defined. Okay, so now that we have split that, how do we access these? It's going to be as simple as a list index. So anytime you have a list, and I don't remember if we've discussed this before, but anytime you have a list, Python is going to automatically index that list. So a list is ordered. The order that the items appear in a list matter. A dictionary is not ordered. It does not matter what order your keys are in a dictionary, but in a list it does. So when you have a list, every single value is indexed. And we remember Python counts starting at 0. So the first value is going to be 0. So if we print player split 0, remember player split is the list. So we print 0, we get the first item, or the 0th item. If we print player split 1, we get the -96, and player split 2, we get the 3 close parentheses. Okay? So we now know how to split that string on characters that we establish, and we know how to return what portion of that split we're interested in. So we want only what's inside the parentheses. So the logical first thing to do, split on the open parentheses and take what comes after it. So let's do it. We're redefining our player split function is a split on the open parenthesis character. Now our player split list is going to be Chris Paul, and the second or the first index wise, so the 0th item is Chris Paul, the first item is going to be the ID with the closed parenthesis at the end. Now, we don't want the closed parenthesis, but we're getting there. So we call the first indexed item in player split is player split 1, and that returns what we want. So now we just need to figure out how to get that closed parenthesis out of there. So we can split it again. So now we're going to kind of do a 2-in-1. We're going to define our ID split, and to do that we're going to call, instead of defining a new variable as just the first index value of the list, we're going to go ahead and use that right inside of this function. So we're going to call the player split first value here, and that returns a string, so we can go ahead and split that string on the closed parentheses. So let's see what that gives us. So closing there, now we can see that if we split on the last character in the string, it's going to return an empty string afterwards. That's good to know. Keep that in mind in case you're doing this in the future and for some reason your counts are off. So if we look at ID split, we get the ID number just as we want it. So let's call the 0th item in that list, and now we have the ID. Bam. So now we understand what we need to do to each cell. So now the question is, how do we apply it across the board to that data frame? To do that, we're going to be utilizing lambda functions. Now, lambda functions are going to be a kind of a unique operation in pandas, or in Python in general, not just pandas. Pandas is just the only place I've used it. So basically what you're going to do is define an x and say, I want to do these things to x. And the nice thing about using them in pandas is pandas has an apply function that you can use combined with lambdas and apply across the entire data frame. So what we're going to do is we're going to define 2 lambda functions, one to get to our player split 1, and then once we have that, we're going to use a second lambda function to get to ID, just to kind of step it out piece by piece and make sure we understand it. So our function 1 is going to be lambda x call.split on the open parenthesis, and we want to return the first value, right? So this should look very familiar, correct? We have split open parenthesis 1. Remember, this was player split was split.open parenthesis, and we return the first value in that list, because we know every single player in this list, in this data frame, is going to be the same format, right? So we know that's going to work, and then we look at the second one, and remember, this one is going to iterate over those values again, so we're feeding in y as basically the player split 1 value. So we need to split on the closed parenthesis, and we want to return the 0th value for ID. Now, looking at the rest of this function, we are calling the call, which is undefined as of yet. What that is going to be the column for the positions, okay? And I'm going to explain this now, and then we're going to kind of step through and then work backwards a little bit to get back to this point. But I want you to kind of be thinking about this as we go. So, and I may be explaining lambda functions poorly. If so, guilty as charged. I very rarely use them, only in pandas, and it works here. So this is how I understand them. So our lambda x and our lambda y, we call that column from that data frame, and for every value in that column, we're going to split and return the first value in that list. For lambda y, we're calling that column in the y, which is representing the data frame again, and we are splitting on the closed parenthesis and returning the 0th item. So if we run that over, we should end up with just the ID numbers in the data frame. So now let's move on and figure out how we can avoid, because we're just calling columns there, but if we look, we don't want to run it over budget or fantasy points per game, right? The values aren't there to split on, the parentheses aren't. So we need to just run it over our positions. And now I know in some previous videos where we've been defining positions and lists, we would do like positions equals, and then we would manually, type these out, right? And that's fine. You only really have to do it once and then you have them, but it's also a pain. So for a situation like this, where we know we want all of them except the last 2, much like we use some string operators here and worked with some list indexes, we're going to go ahead and work with some more list indexes and make this a little easier for ourselves. So first things first, we're going to establish our variable a, and we're going to list out our data frame columns. So if we look at a, caps lock, if we look at a, we just returned all of the column headers for this data frame. Now, getting back to our list indexes, we saw how to pull out a single value, but what we can also do is establish a range of indexes, and it will return just those values in the list. So if we look at a, so we have all of a here. If we look at a, so the way we do this, if we put a semicolon in and leave everything else blank, that means we want to go from the beginning to the end. So we should end up with all of a again. If we do a 2 on the left-hand side, that's going to say we want to start at the item in the index or item in the list that has an index of 2 and go to the end. So that would be 0, 1, 2. So that means we're going to start at shooting guard and go to the end. Okay? On top of that, we can define where we want to end. And there's two ways we can define, or there's two ways we can do either one, really. A positive number is going to count from the front. So if we do 2 to 5, we're going to get 2, 3, 4. Because remember when we worked with ranges, Python is going to stop one value before the end of the range. This is going to be an exclusive ending point, right? It does not include that value. It's up to that value. Up to, not including. So we can do something like that, where we define the range we want specifically. Alternatively, we can define a negative number, and that's going to say we want to go from the second item in the list to the third from the last. Okay, so we're going to go to power forward 1. Let's come up, check here. 1, 2, 3. We're skipping out the last 3 items, because remember we go up to, but not including the one we mentioned, and we defined the third from the last, which is there. Or I guess it's counting, so I mean that would be first from last, second from last, whatever. You're basically starting out backwards, except -1. So let's do -1. Yeah, let's just do, just so we can kind of see how the counting is, let's do a -1 is fantasy points per game. So -1 gives you the last value. So that's -1, -2, -3. And then it's still going to go the same way. It's going to start on 2 and go up to, but not including -3. So if we want all but the last 2 items, we can simply drop in this, and that's going to say we want to go A from the beginning, up to, but not including the second to last item in the list. And that gives us just the positions. So this right here takes a lot less time to type out than manually creating that list for yourself. And so now we can just go ahead and define our positions variable as the list df columns, and then just throw right on the end of that from the 0th item up to, but not including the second from the last item. And that's going to give us the exact same thing as breaking that out. So we have our positions. We want to do for call and position, so that's going to, each of these is going to be passed through when we use the call variable there, which is just short for column. Nothing special about that, just make sure it matches what you're defining here if you're going to use it in a loop like that. So for each of these, we want to df call df.apply function 1 axis 1. Now it's important that you define axis equals 1, because that's going to say that you're looking at columns. Otherwise, I believe it defaults to axis 0, which is rows, and we don't want to do that because that's going to include those last 2 columns that we're not interested in. So let's see, if we run our lambda function 1, function 1, oh, did I never run that? So now that we've defined those lambda functions, if we run our function 1 and take a look at it, we are left in every cell with the player split 1, which is what we should be left with. So we know that worked fine, that's good. Now, if we run function 2 after that, the exact same setup, just running function 2, now we get just the IDs there. Great. So now we could go ahead and export that out. Absolutely no problem whatsoever. And now we have them in the right order. We have the IDs being used correctly, and that is each lineup. And you will notice we didn't work with exposures at all this time, so we're going to have a whole lot of repeats there for small forwards. I guess I really like those 2 guys. But that's how we get it out. On top of that, we can make it a little bit cleaner by putting them both in the same for loop, because that we're going to hit this one first. So it's going to loop over each column, and it's going to run the function 1, then the function 2. Move to the next column, function 1, function 2. Next column, function 1, function 2. So we can run that List index. Oh, that's because we already ran it. Yep. So since I didn't redefine the data frame, it's already been ran. So when we split, just to explain what this error is, list index is out of range. Okay, that means that in our lambda function 1, when we run the split on open parentheses and try to return the first value, there is no open parenthesis to split on. So the whole thing just goes into the 0th item in the list, and then there is no first item in the list. That's where that comes from. So if we go ahead and re-export, or no, we don't need to re-export, we just need to recall the data frame. So if we recall the data frame and relook at data frame head, now we can see that we're back to what we originally started with, and we can run our functions in the same for loop, and we get the same output. On top of that, when we get a little bit more comfortable with this type of work, we can actually chain those two lambda functions together. So we can chain these two together is one statement, okay? Because just as we combined our player split 1 dot split, so we're calling the first item and splitting it at the same time, we can do the same thing with our lambda functions. So if we look at it, we start with player equals Chris Paul. We start with player equals Chris Paul, 55072-9623, same as we started with before. And we're going to combine our split functions into one line. So we have player.split, open parenthesis, return the first value, then split that value on a closed parenthesis and return the 0th value. So we run that, we get just the ID. So we can take that same logic and put it right up here in our lambda x statement as function 0. And we can have x call.split open parenthesis, return the first value, split it again on the closed parenthesis, return the 0th value. Yep, so I already returned and we got our original data frame again. So we define our function 0. Now we just have one line in our for loop, for column positions, df call equals df.apply, function 0, axis equals 1, df.head, there we go. So that's going to be how we get our data, our exported line, how we can export our lineups first off out of the optimizer. And then to make it a little bit more user-friendly and save you the trouble of manually going through and pulling out all those IDs, we can go ahead and run this through pandas. And the nice thing about this is it's something you can write once, and then each time when you use it, you just point to the new export from the optimizer and run it again, and run it again. Probably redefine where you're saving it to, but you don't have to do this every time. It's so simple, so nice. So that's going to be what we have for today. As usual, big shout out to the folks over in the Patreon. It's getting bigger every week. More and more folks are joining, which is phenomenal. We've got some great discussions going on over there as far as code base goes and how to do some different things. So we haven't quite got to in the videos yet. So if you're just jonesing for more and you want more and more and more, and you know the 1 or 2 videos a week I'm getting out to you ain't enough, hop on over to the Patreon, hop in that Discord server, and we are off to the races over there. So again, huge shout out to them, huge thank you to them. You'll be seeing this video in about 3.5 hours, and I will have a new lineup projection, point projection video for you out on Tuesday per usual. In that one, we're going to be looking at actually having a more functional setup using like a different model for each cluster. As we kind of discussed last time, you know, having one model for all the NBA is not that efficient, but having a model for each cluster, that's going to get us a lot closer to where we want to be. So stay tuned, hit that subscribe button, hit that like button, hit that notification bell, if you would be so kind, and I will see you guys on Tuesday.